Welcome to today's webinar. My name is Danielle Dougherty. I am a graduate student at the Indiana University of Pennsylvania's Safety Sciences program. This webinar is hosted by the IUP OSHA Consultation Program. This presentation is pre-recorded, but you will have an opportunity to provide feedback and ask questions at the conclusion. The goal of today's webinar is to reduce the risk of health outcomes due to respiratory exposures in cannabis production facilities. By the end of this session, you'll be able to explain how the level of safety commitment can impact a business both positively and negatively, recognize common cannabis industry respiratory hazards and their health outcomes, as well as apply the hierarchy of controls to minimize and reduce hazard exposures. No matter who you are or what your position is in any organization, there is a reason safety impacts you and will impact your job directly. Everybody plays a role in an effective safety program, and that includes the cannabis industry. Safety advocates are often put in a position of justifying the cost or need for safety. Let's look at an example that demonstrates how much it costs when safety falls short. 2 years ago, in January 2022, the first documented case of a cannabis worker fatality directly linked to exposure at work happened in Massachusetts. Like many cannabis workers, her job duties had changed several times since her employment, but the course of this case shows how quickly workers can experience health effects. Within 4 months of starting her job, she began experiencing new or worsening asthma symptoms. They continued to worsen, and within 8 months, the worker suffered a fatal allergic reaction while working in a pre-roll room at the grow. Within 2 years of this fatality, the employer closed that grow where the death happened, as well as its 3 other dispensaries in Massachusetts, completely exiting that market. The company was assessed over $14,000 in fines for safety violations from OSHA, and that number was initially $35,000. And there were also reports that the Massachusetts Cannabis Control Commission fined the company over $500,000 in 2023. Also, by the end of 2023, the family of the victim filed lawsuits against the company's EHS manager, and an HVAC contractor. And the Massachusetts Cannabis Control Commission director at that time resigned by the end of the year. While it can be difficult for safety advocates to justify measures they're requesting to prevent the possibility of an outcome or risk that hasn't happened yet, this death touched on everyone involved in a cannabis operation and provides some examples that can be used to support your needs. It affected employees and their families, managers, contractors, and regulators. There's a reason for everybody to be aware of and advocate for safety. There are also many different studies showing that low safety environments not only increase the risk of fatality, illness, and injuries, they result in lost time, turnover, and low morale, which impact business functions. They result in financial impact like increased insurance costs, closures and delays, more workers' compensation claims, and also, of course, legal impacts like violations, fines, licensure impacts, and lawsuits. While on the flip side, strong safety cultures contribute to the maintenance or even betterment of physical and mental health of their employees, which in turn results in increased trust, better communication. Happier employees are committed employees. They want to stay at jobs. Employees that stay and are happy and healthy are more productive. And when you have an experienced workforce, you can continue building on that knowledge. This will result in competitive advantages like increased compliance. And another aspect of a strong safety program is it does provide documentation, which is backed by action, which is a protection for both the employer and the employees. There is a misconception that because cannabis is not federally regulated, it is exempt from federal regulation. This isn't true. Federal safety regulations do apply to cannabis businesses. OSHA's General Duty Clause establishes requirement for employers to furnish a place of employment free from recognized hazard, and it also places responsibility on employees to follow the rules as well. In addition to the General Duty Clause, OSHA also has a specific respiratory protection standard. There's another IUP OSHA webinar by Brian Broffer that goes into the specifics of the respiratory protection standard, and I suggest you check that out if you want to find the details of this standard. There are also federal EPA regulations regarding worker protection standards for agricultural pesticide applications, and many states also have specific regulations regarding safety. The actual potential health outcomes from respiratory exposures in cannabis production facilities. Prominent exposure concerns are allergies. In general, allergies are an area where there's still a lot to learn about why and how some people develop allergic reactions and others do not. CDC data shows that 1 in 3 Americans have some kind of allergy, and the numbers are growing. The reasons for this are not completely known, but it is known that repeated exposure can increase allergic reaction as well as the severity of the reaction. And the most extreme reaction is anaphylactic shock. Repeated exposure to many substances can cause a process called sensitization. This is what triggers the immune system to create an allergic response after a certain exposure. Baker's lung and popcorn lung are 2 examples of other occupational diseases experienced from repeated exposure to irritating particles or gases. Popcorn lung is another one to pay attention because diacetyl is actually the substance in that incidence, and it's still used in some vapes. Specific states have banned this, but not all states have. It's not gone across the board. So be aware of this substance when you're doing your hazard assessment. Allergy symptoms may be prevalent in cannabis workers. Specific to the cannabis plant, there's research and historical evidence showing that workers who harvest and process cannabis can be more at risk for developing certain respiratory illnesses. At the turn of the century, hemp and textiles were still a very big industry in the United States. So while the legalization of cannabis is a new topic, it is not a new industry. Bisonosis is a diagnosis that many people may not be familiar with, but it is not rare. It's caused by exposure to plant materials used in the raw textile fibers, including hemp, cotton, flax, and jute. Bacteria on the plant material die and reduce endotoxins. So it is the actual toxin that's causing the health reaction here. You can have mild effects that are flu-like symptoms that include wheezing, coughing, tightness of chest, and after the initial exposure at the beginning of the work week, symptoms may improve by the end of the week or over the weekend when the exposure is removed, which also has given this disease the nickname Monday fever. However, there are also chronic effects. So over a long period of time, bisonosis can result in permanent damage to the lungs. COPD is chronic obstructive pulmonary disease, and this is another one that is progressive and also permanent, and was also observed in textile workers. This had a role in establishing the cotton worker and OSHA standard related to cotton fiber exposure. It's an inflammatory lung disease caused by repeated exposure to irritating gas or particulates. Restricts airflow from the lungs, results in chronic cough, sputum, shortness of breath, and wheezing. And of course, it's irreversible. Respiratory exposures most commonly affect the respiratory tract, which includes the nose, throat, and lungs. Symptoms can be as simple as what typically comes to mind with mild allergies, like a runny nose, coughing, wheezing, and shortness of breath. It's also important to know and understand for both employers and employees the medical diagnosis. Dyspnea is simply the medical terminology for shortness of breath, and a lot of these other terminologies. It's important to identify that so that you can recognize potential exposures and how they may be related to or indicate exposures at work. Beyond the eyes, nose, throat, and lungs, symptoms can affect eyes and skin as well. Irritated, red, itchy, or watery eyes and swelling of skin around the eyes and mucous membranes is called angioedema. Urticaria is a medical term for hives and swelling of the skin. And again, it's important for employees and employers to recognize diagnoses so you can identify new or worsening medical conditions. Systemic effects can happen from repeated exposure, from an acute exposure, and also from exposure to other chemicals and substances within the grow. Asphyxiation, headaches, dizziness, nausea, and cancer are all potential outcomes from uncontrolled hazards. To understand what some of the health outcomes can be, let's look at what specifically is causing them. How are you going to do that? You're going to conduct a hazard analysis. This is an overview of common hazards that may be present, but it's not all-inclusive because each site is unique, so it's up to every facility to do a specific hazard analysis based on your operations, because different climates, different growing styles, substrates, strains, levels of automation, and finished products will affect the environmental conditions in the facility. But in general, all facilities have 3 types of hazards: biological, chemical, and physical. Many of these biologicals already look familiar to those of you familiar with the industry because they are part of most state regulatory sampling requirements for finished products of legal cannabis sales. The reason for this is due to the potential for these things to cause illness when consumed. Because they might be present on finished product, they also might be present throughout the growth cycle. While most of these things are also naturally occurring and unavoidable, and you might get exposure on a regular basis outside of work, conditions in a grow can lead to concentrations or exposure frequencies that exceed normal levels. Fungus and molds produce spores and mycotoxins. They can become activated and grow in the right conditions. For example, aspergillus and its spores can be problematic for immunocompromised people, and the mycotoxins it produces, aflatoxin and ochratoxin A, can produce liver damage in high amounts. Bacteria also are problematic by the living organisms and also for the endo and exotoxins they produce. They're responsible for many different sicknesses, whether ingested or inhaled. We're not going to cover communicable diseases like COVID here because it's best to refer to current guidance as this can change. Plants are also included here because of the amount of anecdotal evidence that certain strains may have more tendency to cause allergic reactions than others, and also because some people seem to have sensitivity to certain strains and not others. Again, there's a lot more research and data needed here. There have been a couple plant proteins identified, and again, a lot of the anecdotal evidence suggests terpenes have a role here in individual sensitivities. More information and data as the industry grows would be a great help here. This illustration is to show how bacteria and mold can exist as a living cell, but the toxins we discussed, the endotoxins that bacteria produce and mycotoxins that molds and fungus might produce, will still be present even if something like irradiation or ozone is used to inactivate the living cells and prevent them from reproducing. The endotoxins, mycotoxins, and exotoxins that were already produced are going to remain an exposure potential. For the chemical respiratory hazards, pesticides can be applied to plant, soil, and in the air. These exposures can happen for both the applicators as well as anybody entering the space or contacting the treated material. And this isn't limited to just the plant material. This can include soil as well as the pots and containers. Solvents are used to separate plant material from and the various plant compounds that are being used or removed. These include hydrocarbons, ethanol, and carbon dioxide. Carbon dioxide can also be pumped into grow rooms using portable tanks or permanent systems. Isopropyl alcohol is used for cleaning purposes, and bleach and acid cleaners. This is something to be aware of. Many people don't know, but bleach and acids can mix and form a deadly combination. So be aware of your chemical inventory. Physical respiratory hazards include dust and particles, low oxygen atmospheres, or chemicals, including some of the solvents used, as well as the possibility of carbon dioxide exposure, and toxic atmospheres as a result of pesticide applications or inadvertent fires. Plastic, when it's burning, releases hydrogen cyanide. There's a lot of electricity and water in these grows, so fires are not uncommon. It's important to understand that hydrogen cyanide smoke can be fatal in a few breaths in high concentrations. So construction materials, contents of a room, HVAC and fire suppression systems all greatly affect the conditions of a space in the event of a fire. So it's important to have a solid emergency response plan. And this is also a time when you're designing the room, you want to talk with your engineer and your fire safety engineer to discuss what the best system is going to be for your facility. Once you've identified the kind of hazards that exist in your facility, you want to drill down to who is specifically exposed and where those exposures happen. Vegetation in flower rooms, this is high humidity and moisture along with growing substrate, soils, cocoa. This can lead to molds and bacteria exposures. Pesticide exposures are more likely here. Following worker protection standards for pesticide applicators and handlers and ensuring everyone is trained on re-entry time will reduce exposure risks. If you're using mobile or fixed CO2, rooms should also have CO2 monitoring and alarm systems. Harvest and trim rooms and spaces are a place to pay a lot of attention because the plants are being cut and trimmed and moved around a lot here. So this physically creates more skin exposures and increased particulate matter from airborne mold, bacteria, toxins, and also the substrate and plant materials. A lot of time these spaces may or may not have been designed for the job function that's happening here. There might be equipment in place, but the actual room may not have been designed in the same way that the veg rooms say. A lot of thought is put into designing spaces to keep plants healthy, but once you exit the grow room, a lot of times facilities modify their operations as rules change or as finished products change or as the business grows. So other functions might be moved around and the spaces weren't designed for human occupancy or necessarily the jobs that are happening in that room in the same way that thought is given to plant needs for ventilation and air filtration. At dry and cure, because the plants are hanging for a few weeks to a few months, yeast and molds can be an issue. Usually environmental controls are in place because they're designed to maintain plant quality throughout this process, and that mitigates human exposures. And a reminder that while ozone and irradiation may or may not be in use in the facility, anywhere they are used, that should be clearly identified. And it's also a reminder that, again, you can kill or inactivate living molds and bacteria, but that is not going to eliminate the toxin. So any toxin that was produced is going to remain. Extraction and processing rooms are where you'll find the solvents and VOC exposures. The most common hydrocarbon solvents are butane and propane. Facilities that have labs may also have some other chemicals like hexane or chloroform. Those are a lot less common. Other solvents, ethanol, carbon dioxide, and typically these rooms are also designed and required to meet fire code requirements for C1D1 and C1D2 flammability hazards. So that comes with ventilation and environmental alarms that are going to reduce possibilities of human exposure because of the ventilation in place to reduce the risk of explosion. So that engineering feature really controls exposures here. So excluding malfunctions, volatile organic compound exposures at this point are most likely when releasing the plant material and opening and closing the extraction vessels. Also, depending on where the extracted material is off-gassed, that also presents an exposure risk. Packaging is another area where it's really good to look at whether or not that space was designed specifically for what is happening there. And different products have different risks associated with it. The fatality reviewed at the beginning involved pre-roll production and included grinding of plant material in this room. Keef is another very fine dust that can present a respiratory hazard, even in rooms where there's no grinding happening, and as well as any other ingredients that are a fine powder that could become airborne and inhaled. There are also other less likely but still potential exposures that might happen within a facility. There are a lot of fire hazards in cannabis grows because of the amount of electricity, water, and some of the processes being used. We discussed the accidental fires. And again, hydrogen cyanide is something can't underscore the importance of understanding how toxic that can be. So just a couple breaths, even if it looks like a small fire, could cause injury or death. Sulfur burners, when they're in use, understand that the smoke created from a sulfur burner is sulfur dioxide. When it reacts with water, including the water in the mucous membranes of your respiratory tract, it turns into sulfuric acid, and that will burn the lungs and prevent oxygen transfer. So it's important to control exposures of that. Less likely also areas where you're going to have generators or idling vehicles that produce carbon monoxide, and of course malfunctions and leaks. So we've identified the hazards. What can be done to mitigate this? How do we control this? The hierarchy of controls are the optimal steps taken to control a hazard, beginning with elimination. Here at this elimination stage, taking the extra time when you're building a facility or in the stages of renovation, really take the time to look at all the processes, not just the environmental needs of the grow room, but look at the kind of environmental needs and hazards that the plants have, but also that the workers in the facility have, taking the time to create a facility that can accommodate future business changes as well as process changes will be well worth the time and money saved to avoid production delays by retrofits and workarounds. Also, while compliance is always a goal, look beyond regulatory limits. Different states have different requirements. A lot of federal requirements apply, but they're not the most strict standards. Look at other industry organization best practices and consider implementing that, and also anticipate regulatory changes in the near future. Once any hazards are eliminated that you can eliminate, the next step is substitution. Because many of the hazards are related to the plant itself, they're not going to be eliminated, and options for substitution might also be limited. In the case of the chlorine and acid cleaner interaction we discussed earlier, substituting one of those products with something that is non-reactive eliminates the potential hazards. Just a couple of years ago, a young restaurant manager died because there was an accidental spill of two cleaners, one a chlorine bleach-based cleaner and the other an acid-based cleaner, and unknowingly these substances mixed on the floor, and while he was cleaning them up, they damaged his lungs so badly that he died even after he was removed from that situation. So a simple substitution of cleaning products could prevent a situation like that from even being a potential. The only other thing I can think of here is for facilities using loose diatomaceous earth or filtration media like charcoal. These present an inhalation hazard. And while OSHA has published several letters of interpretation regarding diatomaceous earth and silica requirements, which have their own specific respiratory requirements, you can avoid that question altogether by using preloaded filters instead of handling loose filtration media in your facility. If anyone has any other suggestions here, I'd be happy to hear about them via email or the contacts at the end of the webinar. The third control in the hierarchy is engineering control. When the hazard can't be eliminated and it can't be substituted out, you use engineering to minimize it. For respiratory hazards, HVAC and air filtration systems will play a big role here. Also, automatic sensors, audio and visual alarms, and other mechanisms that trigger alerts so that safety isn't reliant on a human decision or observation of the environment. This is also where appropriate plumbing and fire systems are important. Water leaks are significant contributors to mold growth or inappropriate drainage. Something to consider also is what the best fire needs are for your facility. High pressure sodium bulbs, sulfur burners, and electrical shorts can all cause fires in a grow. However, due to the height of the ceilings and what type of sprinklers you're using, heat activated sprinklers may not be initiated for quite a while if a fire breaks out. This can significantly affect the amount of smoke produced before any kind of fire control is initiated. So again, this is something to talk with your engineers and your fire engineer about what the best system is for your facility. The next step is using administrative controls. These are designed to reduce hazard exposure by changing the way people work. The limitation is that administrative controls rely on human behavior, so errors will happen. However, understanding that, having good administrative controls in place, there will be multiple hurdles so that a single error won't necessarily result in a catastrophic failure. For example, training is a big part of this. Knowledge is power, and well-trained management and staff exhibit better communication. Another step to take here is to reduce access to high hazard areas. Key card entry, locks on areas where pesticides and other chemicals are stored and applied, and allowing only trained employees to have access to those areas will reduce plant exposures and also creates a second hurdle. A third hurdle is having an emergency action plan and following it. Confined space entry isn't a common cannabis feature, but many grows do have large nutrient tanks. In other industries, confined space entry is a high-risk hazard that results in multiple fatalities when procedures aren't followed. So if you do have a large tank and confined space possibilities, this is a very important administrative control to have in place. Housekeeping, these are all administrative controls. Another way too is to reduce employee exposure. If you can't reduce the risk, you can also rotate employees to limit employee exposure. PPE is the last line of protection in the hierarchy of controls, and it's the last resort for controlling exposure to a hazard. PPE is also required under the federal worker protection standards for pesticide applicators. There's training and certification requirements to train other workers on re-entry interval requirements. And the labels for the agricultural use requirement indicate the specific directions for mandatory PPE use. In addition to EPA requirements for PPE use for worker protection standards, OSHA also requires PPE use when effective engineering controls are not feasible, or while they are being instituted, appropriate respirators shall be used. And the respiratory standard also states that a respirator shall be provided to each employee when that equipment is necessary to protect the health of the employee. In addition to the general requirement that the respiratory protection standard sets for employers to protect employees from certain exposures, this sets the permissible exposure limit. These are regulated, enforceable limits for various contaminants at certain amounts, usually measured in milligrams per cubic meter, with a time-weighted exposure limit, meaning the exposure must happen for 8 hours. Recommended exposure limits are only recommendations, but they are the best practice standards that provide risk reduction above and beyond regulatory limits. So this still leaves gray area, as we'll see on the next slide, because just because something is compliant doesn't necessarily mean there is no hazard. As we had discussed, certain employees may have more risk and more allergic reactions to certain substances. So risk can't always be defined by one number. This is an edited version of the full PEL table that's listed in the respiratory standard. This just lists a couple of the chemical and physical hazards that we discussed earlier for reference. So specifically about that gray area that we talked about, for example, here is the PEL for cotton dust and the PEL for particulates not otherwise regulated. You can see there's quite a difference. And the reason for that difference is because in 1971, due to the amount of health outcomes that workers in the cotton industry were experiencing, OSHA set a reduced limit specifically for cotton dust. And in 1978, the cotton dust standard became enforceable. This has reduced bisonosis in cotton workers from 20% to 1%. And again, this is revisiting what we discussed earlier. Endotoxins are chemicals produced by bacteria on the natural fibers. So it's not just the cotton dust that was the risk, but the endotoxins. Endotoxins are something that are also present on cannabis and also a risk in cannabis. But because cannabis is not specifically listed as the contaminant, the legal enforceable limit is the higher particulates not otherwise regulated. However, if you're doing a risk assessment, this is very important information to take into account and consider. To put this in a different way, when the PELs and OSHA were created in 1971, 50 years ago, a lot has not changed since then, despite the fact there's been a lot of technological, science, and medical advances. So there needs to be a little more research and discussion, and internally for each business needs to make a decision whether or not a regulatory PEL set 50 years ago is the only way to determine if a hazard exists in the workplace. Again, it's really recommended to follow recommended exposure limits and other industry best practices, but those aren't enforceable. The gray area we discussed is the PEL does set a compliance limit, but is that the only thing that determines compliance? The OSHA General Duty Clause does say that an employer has to furnish a place of employment to employees that is free from recognized hazards. But the interpretation of recognized, there's room for interpretation with that term, recognized hazards. Most cannabis facilities are going to have a written respiratory protection program because of pesticide use. However, even those facilities that are not using pesticides that trigger WPS standards may still need a written respiratory protection program. Whenever respirators are in use, this is required as per OSHA's respiratory standard. There are also elements in place for requirements that employers produce the equipment, the training, medical evaluations, fit testing, and ongoing programs to evaluate the effectiveness, as well as record keeping, documenting that this was all done appropriately. And remember, don't limit the PPE to respiratory PPE. This also includes skin contact because the allergic reactions also contribute towards respiratory reactions as well. Long sleeves, long pants, gloves, head coverings, glasses and goggles. These will help protect high-risk employees during high-risk jobs or in areas of high exposure. Medical evaluations are required as part of a written PPE program. Pulmonary function tests may be required in certain instances. However, they're a great tool for measuring baseline lung function, so it's a good idea for any employer to consider these. Spirometry measures the lung volume and output. Chest x-rays can reveal fibrosis and other conditions. So by establishing a baseline, employers and employees understand where they're starting out with. This allows you to identify new symptoms, worsening symptoms, as well as identify high-risk workers, jobs, or trends in the facility. Remember, just because somebody starts a job with a condition like COPD, which is going to be common in smokers, just because they start out with a pre-existing condition, this doesn't exempt the employer from the responsibility to protect the employee from worsening symptoms. So hazard identification and hazard exposure control is an ongoing process, and safety really has to start with management. Management commitment to support employees and support strong safety programs is necessary. And like we talked about, you can Google many of these best places to work surveys and research showing that the same kind of things that are going to create a strong safety culture also create positive work cultures that result in better workplaces overall, not just for safety performance. Management commitment directly impacts employee communication, trust, and contributes to a healthy workplace in general. You also want to look at revisiting this process at least annually and when processes or products change. Technology, research, regulatory requirements are constantly changing. So you want to stay aware and reassess your situation whenever these kind of things happen. Conduct environmental assessments periodically to keep up with how your facility may be changing over time also. And finally, continue to reduce exposure outcomes by using your medical monitoring, identifying new and worsening symptoms or at-risk employees. It doesn't always have to be a doctor's appointment. It could be simple as employee surveys. Also, track your injury and illness rates because these can reveal trends in your facility. And when a trend is identified, that allows you an opportunity to make a correction. A lot of research, growth, and change are happening in cannabis and will continue to happen. The more we learn and share, the more that'll help us all contribute to improving the industry. If you have questions, please pop them in the chat and we'll try to answer them, or send me an email or contact the IUP OSHA Consultation Office. I appreciate your time and attention. That concludes today's webinar. Thank you for attending. Please consider signing up and subscribing to IUP OSHA's YouTube channel so you can be notified of new webinars as they are published. And if you have any feedback or information, questions, please email me at znrdc@iup.edu or call the OSHA Consultation Office at 724-357-4095. Again, thank you very much for your time and attention today. Thank you for attending.